And here we have James Crawford from Orbital Insight. He's going to talk about analyzing satellite imagery. Can tell us if Walmart or Home Depot has more shoppers and if there's large or small oil reserves and many other things.
That's right.
Take it away.
Thanks, Evan. Very happy to be here. So I'm James Crawford from Orbital Insight. So our company is based on, as many software companies are, a fundamental change in the hardware world. And that fundamental change is expressed very nicely by this image. These guys are people. And on this stage, they're almost life-size. But most of the time when I show this presentation on a normal screen, they're really small. This is what satellites are going towards, where Planet Labs launches them 20 at a time. Now, in the past, satellite imagery was interpreted by armies of people going back to the days of the Cuban Missile Crisis. And there's actually still thousands of people in Virginia whose job is to stare at satellite images every day. But as we start to fly not ones, but tens and eventually hundreds, soon hundreds of satellites and also UAVs, that doesn't scale anymore, which is why we're here, why we're excited about machine vision, and why we founded the company. So we're interested in processing petabytes of satellite imagery, and more than that, determining what we can learn from them, because the most a human can look at is about 1 million pixels, but we've already run cases where we've analyzed 4 trillion pixels, and so we can learn things about the world that we never knew before. Now, if you're a startup and you just got your seed round and you have to show customer traction right away in order to get more money, you start with hedge funds. The reason we did this is that they really want to know about the world. They're like race car drivers. They want to be 1 second faster than the next hedge fund. And if you can tell them something they don't already know about the world, they will pay you really soon. So we've had sales cycles of 2 days to get contracts signed with some of the hedge funds. In the longer term, there's a ton of other applications that I'm going to talk about somewhat at the end. So one of the large projects that we've done is looking at U.S. retail. Here we analyzed 1 million parking lot images. As I said, about 4 trillion pixels. We counted 700 million cars. And this system is still running on a daily basis with imagery being uploaded from Digital Globe and also from Airbus that we're counting cars on an ongoing basis. And we're now tracking 50 U.S. retailers. So we can look at the data, 700 million cars, in 2 different ways. One way is to look at a single parking lot. This is a heat map over 6 years of where people park. And you can see they mostly park by the entrance doors. Or you can cut the image the other way, longitudinally, and look over time. And here you can see when people shop as a function of time. I don't know if this laser pointer, yeah, there we go. So this is Christmas. This is the summertime. And then if we zoom in on just Christmas, you can see Black Friday and then the Saturday after Black Friday. All this comes out because we're working at scale. You wouldn't get this if you looked at a few parking lots, but because we're looking at literally 1 million parking lots, we can pull out these sort of signals. This is Ross, actually, and we found out the worst day to shop at Ross, of course, is Saturday, but also Wednesday is pretty popular. At first we thought this was a bug, and then we realized they have a senior discount day on Wednesday. So all the seniors are shopping on Wednesdays, and that creates the secondary peak. Now, since this is a machine vision conference, I wanted to show you just as much as I can in 10 minutes how we actually do this. So this is done with deep learning. We had the humans go through about 200 images and put little red dots on the cars. And this is actually what the tiles actually look like. You can see at 50 centimeter resolution, the cars are not that obvious. You can make them out, but they're not like plain as day. But we had humans go through and mark them, and then the neural network uses a sliding tile to actually create a heat map of how likely each pixel is to be a car pixel. And then we take that heat map and turn it into a count. In this case, a result that says there's 47 cars in this parking lot. Fortunately, since we're using so many images, we don't have to be exactly precise on every image. So we can tolerate single-digit errors in precision on single images and still be able to get this kind of results, accurate results at scale. From an investor point of view, a stock market investor, you also want to look at pairs trading. So this is the kind of thing that really speaks to the guys up a few miles north of here, the actual traders. So you can see Home Depot versus Lowe's, with Home Depot in the yellow, Lowe's in the black. Back in 2009, they were almost neck and neck. But if you look in 2014, Home Depot was ahead almost every month of the year. And right after we put this chart together, Home Depot had their best quarter ever, and the stock went up 5% in one day. We didn't predict quite that much of an extreme result, but we were more accurate in our predictions than the consensus of the Wall Street forecasters. We also look at longer-term trends, and we have tons and tons of slides on this, but I'll just share one, which is, if you remember the polar vortex of 2014, when basically winter failed to end, usually, when we look over multiple years, there is a trough in January, but it's usually pretty shallow in time. But this one was much broader. So we can definitely see, and this is sort of the wisdom on Wall Street, that bad weather in the Northeast depresses retail sales, and we actually have enough data now to start to actually see that effect occurring. It's not all about car counting, though. We're also looking at a half dozen other applications, and I'm going to talk briefly about two of them. One of them is construction in China. If you talk to the guys, the investor community, there's huge division about China. Some people say they're building these things the size of Lower Manhattan and nobody's living in them. Other investors believe that they are appropriately building because so many people, there's such a large population of 1 billion people that are starting to move in from the countryside. So our role here is not to resolve that. Our role here is to count the buildings and count how big they are. This is actually really hard from a machine vision point of view. You're looking from above. You can't really tell how tall these buildings are from above. We've been focusing on counting shadows, and I just pulled out a few of, these are actual tiles out of our system to show you how challenging that is from a machine vision point of view. Because those are shadows, this is a shadow with a hole in it, this is a shadow in a really dark image, this is a shadow in a really light image, which is actually lighter than the lightest pixel in the really dark image. Nevertheless, the neural networks are getting to be pretty good at this. This is actual output where we start from the image. We create a heat map of how likely we think each pixel is a shadow pixel, and then we create our actual assessment of where the shadows are. And we've been running this on a set of commercial developments of known gross square footage, and we found a 0.96 correlation between the shadow pixels and the known gross square footage. We're just in the process of rolling this up to run it at a city level and then a national level. The data on China is amazingly bad. So one of the biggest challenges in this project is there is no good objective data to tell how good we're doing. But that also means the data source, once we build it, will be one of a kind in terms of how quickly people are putting up buildings in China and then other countries as well. The last one I'm going to talk about is oil. As you may have noticed, the price of oil has been going down quite a lot. And part of the reason for that is the world is literally running out of places to put crude oil. So what we've been doing here is we've been looking at these floating lid tanks. Crude oil is almost always kept in tanks with floating lids. This is a cutaway picture. The reason they do this is that if they don't do it, the volatile fumes from the oil will get out into the environment, and they may actually explode inside the tank. So the lid floats, it sits right on top of the oil, and because the lid sits right on top of the oil, it creates these nice little crescent moon shadows for us. One of our machine vision leads, Boris, has been working on this, and he's here, so you can find him and get him to try to tell you the secret. I'm not going to tell, but he has a new algorithm that gets amazingly good results. All the red lines on that picture are machine generated using the algorithms, and we can actually find both the outline of the outside of the tank and the line of the shadow demarcation in the tank. And by looking at the distance between these two lines, and a little bit of trigonometry based on the sun angle, we can compute how far down that floating lid is. There's about 14,000 of these tanks around the world. Nobody actually knows how much oil is in all of them. So when we put this signal together, as we start to scale it out, we'll have the first real picture of how much crude oil is in the world. And this is one of the biggest drivers. As with any commodity, the amount of the commodity in the world is one of the biggest drivers of the price of that commodity. So this will be the first time we have a real-time picture of the amount of crude oil, especially in places like Asia, where the data is, in the Middle East, where the data is just not good. So, as I said, there's a bunch of other things we're working on, predicting crop yield using multispectral analysis, looking at projecting deforestation, looking at road building as a predictor of deforestation to identify areas that are at risk, measuring bulk commodities. It's an extremely long list, and so on the strength of that, we raised an A round, which has been in the press earlier this year, about almost $9 million, led by Sequoia Capital. And we're in the process of building out these and a number of other applications. And that's my summary.